Hi there, my name is Conor and I'm a Customer Success Manager at Silico. Silico is a new business simulation platform that allows you to create a digital twin of your enterprise. This allows you to monitor your business in real time, forecast its future state under different scenarios, and simulate the impact of different decisions on important outcomes within your business so that you can test decisions virtually before implementing them in the real world. In this short video, I'm going to walk you through the 3 different basic building blocks of a Silico model, which are variables, stocks, and flows. So let's start with variables. To add a variable, we just have to right click on the model builder page, or we can use the shortcut of pressing V, and we have a variable added to our model builder page here. So if we double click on this, it opens up the inspector, and if we go to the data tab, we can essentially see that a variable is just like a column of cells in a spreadsheet with time running from top to bottom and a value here being held for each time unit. So in this case, we run the model from January 1st and we're running it in weeks and intervals of weeks. So there's a new value held for the start of every week, and we're running that all the way down until December 30th, 2023. So that's the simulation period of this particular model that we've set up. If we open the inspector again and put in, let's say, 5 within the formula, we can see here on the graph that changes what's held there. And if we go to the data tab, we can also see that 5 is now the value for all of those different weeks throughout the simulation period. So generally speaking, it's easier to understand the differences between variables, flows, and stocks if we ground it with an example. So let's imagine that we're the CFO of a soft drinks company, and let's say that we want to use a Silico model to forecast what our sales might be towards the end of, let's say, December 2023. So one of the variables that we might use in such a model would be the rate of sale. So by that we mean the number of drinks that we're selling for every store that we're stocked in. So if we click here again, we can change the name of this variable to rate of sale. In the stub field, we generally recommend that you put the units of what you're trying to measure, so of this particular variable. So let's say that's drinks per store per week in this case. Per week, because again this model is being run in weeks. Now let's say we look back at historical data and we see that on average we're selling 10 drinks for every store that we're stocked in on a weekly basis. So we can set the formula to 10. We could of course integrate this with the actual data that we have, but for the simplicity of this example, we'll just keep that value as 10. So one of the other variables that we'd want to measure in this model would be the total drinks sold. So that's the ultimate kind of variable that we're really trying to forecast. So the units of that would be, again, drinks per week. And the formula for that is actually going to depend on other variables. So rate of sale is going to be one of them. So we can see there that that's now an input that's required. And another variable that will be required is the number of stores that we're actually stocked in. So the number of stores that we're stocked in is something that actually accumulates over time. For that reason, we're going to model it as a stock. So stocks represent points of accumulation within the system. So any variable that accumulates over time would be modeled as a stock. So think of things like population in a city, which accumulates by births and deaths. The number of goods in a warehouse, which would accumulate by goods shipped in and goods shipped out. The number of employees in a business, which is accumulated by hiring and people leaving, and other things like the cash on a balance sheet, which is increased by money added to the bank account and decreased by withdrawals from that account. So in this particular case, the variable that we're looking at now is the number of stores that sell our product. That's going to be introduced also as a stock because that represents an accumulation of all the listings that we've won over time, so all the stores that have started selling our product, and is decumulated by all the stores that have stopped selling our product over time. So if we click on the stock variable here, we can name this then to stores that sell our product, and the units there is just going to be stores. And for a stock, what we want to give it is just an initial value. So we give it the value that it's going to have at January 1st, 2022. So let's say that we had 600 stores then. And of course, if nothing changes, if there's no effect on this stock, then it's going to remain at 600 over time. So what we want to introduce now is to represent the fact that we win and lose stores. And that's done via flows. So flows are used to represent how stocks change over time. So there's 2 types of flows essentially. There's inflows and outflows. So inflows increase the value of a stock, whereas outflows decrease the value of a stock. So again, if we right click, we can introduce a flow through this clicking just here, or else we can press F as a shortcut. And inflows look like this. The flow arrow is going in towards the stock, whereas outflows look like this, where a flows coming out of the stock. So inflows, as the name suggests, increase the value of the stock over time. The stock will accumulate that value, whereas outflows decumulate the stock over time, so they will deplete the value of the stock. So in this case, as we mentioned, the flows would be the number of stores that start selling our products, so let's call that listings 1 per week. So that's the inflow that we have here, and then the outflow would be listings lost per week. And the units here will be stores per week, and the same here as well, so stores per week. So generally speaking, the value of all flows is going to be over time. So the value of a stock is generally at a point in time. So if we look here, it's 600 at a certain point in time, whereas the value of a flow is a value over a period of time that changes the stock over that period. So for example, let's say we were winning 2 listings per week on average. So we can put the formula here to 2, and we can see how the stock changes over the simulation period. Before it was staying steady at 600, now it's accumulating the value of 2 for every week, and there's 104 weeks, so that brings us to 808 in total. And we can see with the time bar down here how that changes over time and accumulates by 2 for each week that we go through. So we also want to represent what happens with outflows, so the stores that are lost per week. Let's say that on average we lose 1 store a week. So now we can see how the stock changes from 808, and when we introduce the representation of this outflow, it gets to 704 instead by the end of the simulation period. So the net increase in stock is now just 1 per week. With 104 weeks, it goes from 600 to 704. So one of the most important rules around stocks is that stocks can only grow when the inflow or their inflows are greater than their outflow or outflows. So in this case, 2 is greater than 1, so that's why we see a rate of growth of the stock. However, if we were to lose, let's say, 3 listings a week, we would see our stock decline from a starting place of 600 down to 496 by the end of the simulation period. And at the same time, if stock's inflow is equal to its outflows, then it is in a state of equilibrium, so it won't change over time. So there's 2 coming in every week, 2 being lost every week, and therefore it's just going to remain the same at 600 for every week. Okay, so that has introduced the concept of variable stocks and flows, and we'll come across these again throughout this video series, but for now we can just finish the model that we've started. So we want to calculate the total drinks sold, we know the rate of sale, now we know the number of stores that our product will be stocked in, so we can use those to determine the total drinks sold. So we can click in here and we can write our formula of the stores that sell our product multiplied by the rate of sale. That's going to give us the total drinks sold per week. So what's happening here is that the software is basically matching up what the value of this variable is for a given period of time multiplied by what the value is for this variable over a given period of time. So for example, if we go down here to the time bar and we go to the week of, let's say, December 10th, we can see that there was 649 stores selling our product that week. There was a rate of sale of 10, so therefore the total drinks sold in that week would be 6,490. Or if we change to another week, we can see 673 multiplied by 10 is 6,730. Okay, so that concludes the model for now, and that concludes the video for today. We hope you've learned a little bit about the difference between variables, flows and stocks, and we'll be introducing these concepts again in upcoming videos, so we look forward to introducing that content to you soon. Thanks again for your time, and take care.